I collaborate often with a team, a data science and scale team at Los Alamos National Labs. I started out there as a visiting artist, and I've morphed into something ambiguous, okay? And so today I'm going to present a paper with Lynn Bartram from Simon Fraser University, where we looked at the affect theory as well as kind of artistic color contrast theory to see how it might impact scientific visualizations and the engagement with scientific visualization. So we're going to look at three things. One are palettes created from the expertise of the artistic community, and whether we can use those to create effective and affective communication, and mining the balance to optimize the complex relationships of views and selections, which is what artists are good at. You know, guys, I'm gonna so this is a painting. It's Monet in his studio boat, and on the right-hand side, you see an example from the affect color theory, which I'm going to show you later. I have to have my notes. I'm sorry. I apologize, but let me figure this out. Apologies, this is what I get for getting a new computer. Okay, here we go. All right, so we're going to put a number of examples of paintings, and I will put a preface on it that most of the paintings are over 100 years old, and I'm sure you can guess why that is, and it has to do with copyright laws. So what we did was we looked at these paintings and we extracted palettes from the paintings, and then put them together with color maps to see what the result was. So if you look on the left, you have Cézanne's fruit on a table, maybe it's pears on a table, and also the color maps that I built from kind of extracted palettes from the painting. And then, thank you, and then just to the right is ocean currents, visualization of ocean currents in three different palettes. And the first one is drawn from the Cézanne painting, and the second two are the rainbow and the cool warm color map, which if you've seen much at the conference will be very familiar to you. Now this is a little bit cheating because the Cézanne palette has multiple color scales in it, but it's worth a note, and our point here is not necessarily the density of information that can be packed in by using more nuanced palettes, but what is the affect and engagement of those palettes? So here's an example. I think you might have seen some of the asteroid visualizations downstairs from the scientific visualization competition. And the top row shows the standards from the community, and one that we actually developed on the right, along with examples from some of the palettes that we've extracted from paintings here in the paper, some more effective than others, but just to give you a comparison of some of the iterations that we went through. So this gives you an idea of where we're coming from. So the affect palette research was done and shown at CHI a year and a half ago. And what we found was that those palettes aligned very naturally with the paintings that I had selected without any, kind of planning along the way. But you can clearly see the contrast of Matisse on the left with the playful palette, and Goya on the right, not such a pleasant subject, with the negative palette. Now, I don't think either one of these palettes are particularly effective for the visualization, but it's interesting to see the contrast. So then we need to turn to the issue of what value can we provide to the science, as well as what palettes are best for what types of data. And this is a Picasso, it's a seated woman. He's a very, it contains very distinct ranges and segments of color. It's kind of spattered across the painting. I mean, the red is distributed across the painting, the black is distributed across the painting, and it's meant to move your eye from one to another. There are a lot of competing zones. And so I've applied this to some magnetic reconnection data, and it's because they were looking at seeing specific areas within that visualization. And so on the right, the cool warm wasn't providing detail. I'm not saying this palette's optimal, but I think you can begin to see the path that we're going down. So this is Irises by Van Gogh, and here the palette is becoming more attuned to the data. This is combustion data from Jackie Chen and Sandia, and I think it provides us the flexibility to use the techniques that artists use to highlight specific information and direct attention, and the richness that we're looking for from these artistic palettes. Because I call them the little dragon, the little red dragon, that's the area that they're interested in, that's the hottest area. So we're beginning to align the viz and the color and the needs. In the paper, we kind of outline different ways that artists use contrast theory. And so this is an example of Van Eyck. Van Eyck is a very formal painter, very, very tightly designed palettes, and he's used kind of every type of color contrast in a very targeted way to specifically tell you what is important in this painting. Do we care about that guy? Nope. Poor guy, we really don't care. I think his parents commissioned the painting actually, so that's too bad. But clearly that he's used color to focus the attention on the next generation. So this is in contrast to Manet, who painted Monet in his studio boat, and this is just a detail from the painting, but it's a very calm, serene scene, and your eye sort of wanders around the painting, and it's a meditative painting. It's clearly, Monet is in his boat, he's kind of slowly building his work, and so the palette used here, which you saw earlier as associated with calm colors, provides a good base for scientists looking to peruse their data or explore their data without a specific intent of focusing attention in specific areas. So, so one of the primary things that I hear from scientists when I work with scientists is, help, I need recommendations. You can give me all the color you want, that's all terrific, but I don't know what to use when. So these are not tested, okay? And that's a whole other topic, and we can get to that. But as we looked at what were the intentions of the paintings, for instance, the Van Eyck palette is the first one there on your left. We found that that palette is very good for if you want to direct attention to a specific spot, and then you want to have contextual data, and you want to have a hierarchy of what's important. Whereas the Monet palette, no matter how you use it, the colors are all very equal in terms of what we call attention, how much attention they call to themselves. I mean, not exactly, but they provide sort of an equal balance, and that's better for exploration. So this is in the paper, and we don't do user studies on it, but it's based on just 5 years of working with scientists at the lab. So all of these resources are available. We have a website, it's cibuscolor.org, and what I would say is it's important to realize that not all of these palettes are good for all visualization, and it's not the intent that all visualization needs to have an emotional impact, but we're human and we like engagement. And so I think that we're leaving a lot on the table. The scientific community is primarily driven by perception research, and that the art community has a lot to offer. And I think that it's from that 500 years of tradition of manipulating color and color relationships, that knowledge is ripe to be tapped for this community, because it's not just about beauty and engagement. It's about an artist's ability to use color for specific means and balances, and use complex color schemes as opposed to specific choices. Like, I tell a story of, I used to paint on the sides of buildings, and when you paint on the side of a building, you can't mix the paint on your palette. You have to mix them in tubs, right? And then you carry the tubs up your scaffolding. And I used to have a tub for green alone. It had 40 greens in it, at least, on any given day. And then I had the cool colors and the warm colors. And that's because as an artist, we're used to working with the nuance and subtleties within a palette and knowing how to use them to create contrast and create detail. I call it clarity without cacophony. So this is a tool that's available. We've presented this material before, but it's just briefly mentioned in the paper as a device for how you can apply these palettes to data. And it's called Color Moves. It's also available on the website, and it's a really pretty simple interface, really very easy to use. You simply apply, I call it the magic color map, this kind of fluorescent green color map, which is basically RGB values tied to data values, and apply it. So you drag and drop it into the interface, and then you can see the color scales that are extracted from all those artist palettes, okay, are listed on the left, and you drag and drop them into the histogram down at the bottom, and you can control the ranges of the color scales. So it really is a very flexible tool that allows you to target where you want the primary contrast, where you want the secondary contrast, which are all things that artists take into account. And I think that the scientists I've worked with found it very valuable for exploration. We thought that it would be valuable for communication, but actually it's valuable for exploration. The other issue